All right, hopefully you're coming down the home stretch with this quiz. Not a hard one, I know. It's more just tedious to write everything. So I'll give you another 30 seconds or so, and then we'll see what our answers are. Hopefully you're right. Time's up, pencils down. No, I'm just kidding. I love saying that when it's the day before a quiz or a test. Yeah, so let's go ahead and go over this. If you're still working, that's fine. You can go make your whatever it is. But I'll show you what I've got. And like I said, it's probably just more time consuming and tedious to do this rather than anything really hard. Yeah, this first test is generally everyone gets, a lot of people get A's. So hopefully I'll get to put a lot of stickers on tests this week. But anyway, here's my answer for number one. Let me just point out though, so that you understand how I'll grade this on the exam. What I'm looking for is it's labeled on the bottom. You've got all the labels there. And I realize that this is like, of course, you might be thinking, but you'd be surprised. Another thing that I'm looking for is that you have bars. Some people, I don't know, they do something else. And it's weird. I don't even know why. And then the other thing, this is key, is you've got bars. This looks sort of like a histogram, but you know it's not a histogram. It's a bar chart. And the way you know that is you have these gaps here, gaps. So just to emphasize that on the test on Friday, if it says histogram, then no gap, smashed up against one another. And if it says bar chart, get a gap in there and you'll be fine. Okay, so that's that. Are there any questions about this first one? What do you think, Hayden? Oh, I don't care. Come on. No, okay, yeah. Here, just a minute. Here, no, that really, I don't care. The labels, as long as it's labeled. So you want to do this? Red, orange, yellow, green, blue, indigo? No, it's purple. Oh, well. And then clear. Oh, and by the way, I had a friend, this is 30 years ago when I was living in Buffalo. No, 35 years ago. My goodness. And he liked to say that his favorite color was clear and his second favorite color was plaid, just because he thought that was funny. So anyway, yeah, I don't care. As long as it's labeled. You put whatever you want down there. If you happen to have different, if this is not the question on the test, but if on the test this was the question and you had different colored highlighters and you highlighted each bar with the color, no labels, I'd say you did it. You did a great job. So yeah. All right, let's do the next one. I'm curious. I'm so curious because when I do this and collect it, I get a variety of answers. So I'm curious to see what kind of answers you have. So does anyone want to take a guess as to it's the cat, isn't it? Yeah. What percentage own cats? Okay, Hayden, what do you think? 50%? Anyone want to say something different? Okay. I do get 20. So 25 is what I'm intending, but I'll get 32, 24, 21, 20. That's fine. I'm just in the ballpark. Because yeah. So yeah, this I think, if you look at this, I think it's a little less than a quarter, isn't it? Yeah, I think it's a little less than a quarter, 25, but I'd say I would go 25. If you have anything that is in the ballpark between 20 and 30%, I'd say if you said it was 35%, you're probably not right, but whatever. All right, thank you. Let's go on. I've given you each, or at least I've given each row of people a little half sheet of paper, mainly because I didn't want you to have to copy all this junk down. There are a lot of numbers. And I thought it'd be easier if you just had the data. So if you don't have one in front of you, look to your left or right. You will find a sheet of paper that says classwork on it, and we're going to do this classwork now. We have two things we have to deal with today. This is one of them. The other one is going to be on PowerPoint, so we'll switch gears sort of midway through. So this is largely a review. I realize you did this in 7th grade, all right? So I just want to remind you of some things about this. That's it. So here's what I'd like you to do. We'll go in stages. Let's take a look at the first problem, compute the mean, median, and mode of those data. So let's just see, do you remember from 7th grade what those words mean? Work with a friend if you need to. and then we'll talk about the answers, and we'll move on to number 2. So that's sort of my strategy as to what we're going to do. Okay. All right, most of you are probably finishing up here. It's not hard, is it? So, so what is the mean? Does anyone want to tell me how to compute the mean here from your 7th grade math classes? I know Hayden knows, but I neglected some other hands earlier, so I just want to make sure that no one who's dying to show off their knowledge of statistics. Okay. All right. Oh, yeah. Caleb, thank you. Caleb. Yeah, add them all up and divide by the number of data. That's perfect. So we're just going to do 7 plus 2 plus 5 plus 5 plus 7 plus 7 plus 6 divided by how many there are. 1, 2, 3, 4, 5, 6, 7. There's 7 of them here. And this, let's see, 4, 28, 35. Is it 5? Wait. Is it 35? 39. Okay, I'm doing it in my head. My mental calculator isn't as good as perhaps your calculator, especially these days for the aforementioned reason. So this is going to be what, 5 point, let's see, 35, that's 4, 5.6, 5.6 or so, 5.5 something. Okay, we'll go with 5.6. But you do it on your calculator. Don't trust my mental calculator. Okay, next one, the median, the median. So once again, you remember this from not third grade, probably 7th or 8th grade. What is the median? Do you remember? I know. It's okay. He knows it. Anyone else want to do it? I'm not using my randomizer today, I guess. Oh yeah, you got it, Abby. What is it? What's the median? Oh, I love it. It's the middle number. When you put it in order, that's perfect, because the main reason people get the median wrong is they don't put it in order. They're like, it's the middle. The middle is the median. Yes, after you put it in order. So we got to have people stand in order from shortest to tallest and then find the middle person. So in this case, the median is not 5. You see 5 is in the middle right now. See, 3 on the left, 3 on the right. So we're going to do what Abby suggests. We're going to put these in order: 2, 5, 5, 6, 7, 7, 7. And hopefully you can see it. The middle number is right there. There are 3 on the left, 3 on the right. And so the median, here I should use the correct symbols. X bar is 5.6. That is the mean. The median is capital M, and that's going to be 6. By the way, you can figure out the median, the location. I'll put this over here. Location of the median. A little bit tricky, but you take n plus 1 over 2. That's how you figure out the location of the median, where n is the number of data. Let me just show you what I mean by this. It's like a magic trick almost. How many numbers do we have here? There's 7. 7 numbers. 7 plus 1 is 8. Divided by 2 is 4. Now you just have to count. Well, 1, 2, 3, 4. It's the 4th number. Now, you might say, well, what happens if you get a decimal? Well, if you get a decimal, like if you have 6 numbers, and 6 plus 1 divided by 2 is 3.5. Well, that just means that you're going to be between 2 numbers, and you just pick any number between those two. probably right between them would be the best to do it. But we'll get to that because I think there's an example coming up that is like that. So finally, the mode. Who's got the mode for me? Anyone know that? Without me using the randomizer? Okay, Hayden, what is the mode? Oh, I love it. Oh, wait, oh, thank you, Kirsten. Save him. Yeah, the most frequent. Yeah, the mode is the most popular. Like that's the one that wins the election. So the mode here, mode is going to be the most popular, and it happens to be 7. We don't really use the mode that much, but we do talk about modal things when we talk about statistics. The mode is usually the most popular region, if you will. So the mode, it's not as significant when you're talking about the mode as a single number, but when we talk about the mode in terms of categories, it's the most popular category. Well, let's go on to this one. This is much more hard, more difficult because you have this big long list of numbers. This is from a class from a couple of years ago. I asked them for their current age, and I got these numbers. And so to compute the mean, median, and mode is going to be a lot more time consuming. So you might want to work with a friend here, try to get it done. I'll give you a couple of minutes and then we'll just talk through how to do this as efficiently as possible. Yeah, what do you think? I would love if you used Excel. Yeah, that's fine. Yeah, Excel it has some great, of course, then you got to type the numbers in, but might be less time consuming. Come on. All right, before this is kind of ridiculous, isn't it? Adding all these numbers up. I think we should take Hayden's suggestion. Use Excel for this, at least for the mean. You might have already done the mean because you're quicker with your calculator than me. All I've done is I've sorted the numbers. There's 25 of them, and so I was trying to do the median. So if there's 25 numbers, let's use this little formula up here. 25 plus 1 is 26. 26 divided by 2, 13, right? So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. That number there is the median. Yeah, median. Yeah, adding this up, that's a pain. So I've actually, in order to sort them, I put them into Excel. So just a minute. I'll tell you what the sum is, and then we can compare with what you got. I got 472. Yeah, I don't know if anyone was quick as. So this is, you add them up, you get 472, divide by 25, And that's going to be roughly 19 and a half. So let's see if I'll get it right here. Divide this, divided by 25. Oh, sorry, 18. How did I, really? 18.8? Sorry, 25 times 20 is, oh, I see, sorry. Yeah, my mental calculator is on the fritz. Yeah, 18.8, sounds good. Because 25 times 19 is 475. So it's going to be less than 419. Okay, so this is the mean, this is the mean. And then the mode. Does anyone see the mode? Now that you know what the mode is, you can just shout it out if you want. 19, is that what you said? Yeah, 19. It's the most popular. So there you go. All right, very nice. Next one is, so now things get more interesting, but actually easier. So at first glance, you might say, well, wait a minute. This is going to be, how am I supposed to do this? I've got all of these siblings. So these are data, once again, from a previous semester that describe number of siblings that people have. I think I had a question like this on your survey as well. And so essentially, what this table means is that the data looks like this. 0, 0, 0, there's 3 zeros, and then there are 17 ones. I can't do it. Okay, but you get the picture. Can you imagine what these would look like if I listed them all out? You'd have 3 zeros, 17 ones, and then a whole bunch of 2s, and then 3s, and things taper off as you go down the list. So in order to do this, to figure out the mean, the median, the mode, well, the mode is the easiest one. I hope you see what the mode is. So what is the mode for this particular set of data? What's the most popular? It's 2. Yes, some people are going 2. Very nice. It is 2. The mode that's the easiest when you have a table like this. So I'll write that down. Mode is 2. And that's the way we're going to be referring to modes. The mode is going to be the biggest category. So in future, when we're dealing with statistics. Then the mean and the median are a little harder. So let's do the median first. And then we'll do the mean last, because that's kind of the hardest in this sort of a situation. So first of all, to find the median, I need to know how many. How many are there? So what you're going to want to do is add up all the frequencies and get a total. So how many? Since I didn't specify in the stem of the problem, I need to know how many there are. So you go ahead and add it up. I'm going to see how well my mental calculator is working. So don't shout it out yet. I'm just curious if I can do this. Okay, I have my number. Did anyone add them up? Is it 67? Oh, and it's time, whatever that was. Okay, so there's 67. And so let's use the trick that we know. 67 plus 1 divided by 2 is equal to 34. Very nice. So I need to find the 34th number. Now, this is where things get tricky. You have to use your imagination. What we're going to do is imagine that we have these numbers as a list. So there are 3 zeros. So I'm thinking in my head, 0, 0, 0. That's 3. Then there are 17 ones. So in my head, I'm thinking 1, 1, 1, 1, 1. When I get to the end of the ones, I have 20 numbers that have been on the list. So I'm up to 20. I'm looking for the 34th number. So I keep counting. 21, that number is a 2. 22, that number is a 2. So once again, you're imagining that you've got a list like this that you're counting through. I think you probably all have figured out by now that the 34th number is somewhere in here, isn't it? It's going to be in this group of 2s. So the 34th number is a 2, and so that's the median. The median is 2. And now let's do the mean. The mean is the hardest, sort of. It's not as bad as you might think. So this was 67. Okay, so to do the mean, here's the trick that we're going to do. No, not the mean. sorry, we do this. We're going to do SIBS times frequency. You see, when I was up here and I added up, if I added up these numbers, if you did it on your calculator, you do 16 plus 17 plus 17 plus 17 plus 17 plus 17 plus 18. I'm not going to go any further, don't worry. But when you did that, wouldn't it have been more efficient to do 16 plus 5 17s? So 16 plus 5 times 17. And so you could lump all those together. That's what this does, is it says, okay, we'll take the siblings, since there's 3 zeros, just do 3 times 0 instead of 0 plus 0 plus 0. Back in 4th grade, when you learned about multiplication, that's how they taught you. They said, isn't it dumb to, well, they probably didn't use that language, to say 3 plus 3 plus 3 plus 3. Just do 3 times 4 and get 12. And so it's a shortcut. So we're going to do the same thing here. We'll do 0 times 3 to get 0. 1 times 17, that's all of the siblings for those people. You've added them up now. And then you add up 29 2s and you get 58. You add up 3 8s, you get 24. Now, if you have to use your calculator, don't be ashamed. Do it. You know, like I said, I'm not so confident in my mental abilities this particular week. There's a lot going on beyond the aforementioned issue that we need to deal with anyway. Another story that we can tell another time. But there it is. So I've added up, basically, this is all this. If I were to add up all those 1s, I would get this. If I were to add up all those 2s, all the 3s, all the 4s, and so on. Now let's just get the total of all of those people. And I am tempted to try to do it in my head, but I'm not going to. I should say that every Sunday night, my wife, mother-in-law, and I play board games. And whenever we get done, my wife keeps score, but then she hands me the score sheet and says, "You're the mathematician, add these up." And so I just do my best, but I usually, well, don't cheat. Okay, so then I got 152, so I don't know if anyone else added these up. Okay, so at least I have one independent nod there. Thank you for that. So then you take that 152 and you divide it. So that's going to be the total. That's this total right here. So the mean is 152 over 67. So you're just going to divide by the number of numbers. So divide it by 67, and I got 2.26. 26. Okay, I better go one more digit. 269, so I can round that last digit. Yeah, as far as rounding goes, I don't think I have any, at least on this test. I don't remember if there's any. Don't just give me one. Give me 2 digits at least. I don't know. I'm not picky. I just want to know that you know what it means to be the mean. That's all. All right. Any questions about that one? I mean, it gets harder. I need to back up for a minute though before we do the last one, because I thought, but I guess I was wrong, that there was a problem that had an even number of data. So I just want to make sure that we hit this before we go to the last one, and then we'll switch gears and talk about quartiles. It's not really switching gears, because some of you know what a quartile is, and you say, well, that's basically just a median. Okay, so let's pretend that we have 6 numbers. So those 6 numbers are these: 3, 4, 5, 10, 11, and 20. And these are going to represent, I don't know, the number of coffees that someone has per day or whatever. Like, yeah, I don't know. I remember I've had friends who are like, I drink like 7 Mountain Dews before noon. Like, okay, buddy. I think, yeah, I'm maximum 3, maximum. I had 1 this morning. I might have a second, but that's it. Okay, but anyway, let's see, whatever it is, doesn't matter. You make up your own thing. Okay, so let's say I want to find the median. The median will do n plus 1 over 2, which in this case is 6 plus 1 over 2, which is 3.5. So you might say, well, there is no 3.5 number. You're right, we're going to make one up. So here's what we do. Here's the first number, second number, third number. 3.5 would go right here. Notice that that line splits this beautifully in half, with half on the one side, half on the other. And so because there isn't a real number there, technically, any number in that gap would serve as a median, but so that we cannot have chaos, we're going to just agree that we're going to pick the middle. The middle of that gap will be the median. And so just pick the middle number. Add those two numbers, 5 and 10 together, and divide by 2. You get 7.5. That's the median of that data. Okay, so there it is. One last thing, like I said before, or there are questions about this before? I know, it's pretty straightforward. I figure that probably most of you are okay with, you know, what we're doing. It's like just a review or a reminder of what you did in 7th or 6th grade, or who knows, I don't know when you, most of you are probably advanced math students, so it might have been 5th grade. But anyway, getting back to this, this last one is a little bit different. It says approximate the mean of these data, because it doesn't give you the actual data. This is a grouped frequency distribution. And by the way, this was actually last semester. My class, they said, hey, we want to know the, how, because people have these bottles of water, how many ounces? And so that was the question we asked. And I grouped things. And so you might say, well, how are we going to do this? How are we going to figure out the average? Well, we're not going to get the average because we don't have the raw data. But we can approximate the average. And the way we're going to do this is we're going to take those, let me just pick on one of these categories to sort of explain. So let's take a look at this category right here, right there. You have 14 people who said that their water bottle that they haul around is between 21 and 30 ounces. I'm guessing most of those people were probably 24, but I don't know. It could have been spread out all over the place. But we could say that, we know that it's probably spread out. People are, some 27s, some 22s, I don't know. But just to sort of play it safe, we'll pick a number in the middle of this range, and we'll just say, okay, all 14 of those people, we're going to just assign them that number. And we realize we're going to, this is the way statistics works, is you're going to make a little bit, you're hedging your bets. You know that it's not going to be perfect. This is why statistics never gives you the true answer, but it always tells you the truth. It's kind of a contradiction, isn't it? But it always tells you the truth, but it never tells you exactly what the answer is. You're never going to get you're never going to say, I've proved this, I know the truth. But you're going to be like, well, I know that this is true within these bounds and everything is true. Okay, so we're going to approximate. That's what an approximate. We're going to be reasonably sure that we're close to the truth. That's our goal. Okay, so what number will I choose? Well, unfortunately for us, the number I'm going to choose is the very middle of that particular range, and that would be 21 plus 30 divided by 2, and that is 25.5. So that's what I'm going to use as a stand-in for all of the numbers in that range. Same thing goes for this one. It will be 15.5, which is 11 plus 20 over 2. This one will be 5.5, and you can kind of see the pattern now. And then 45.5, 55, and then 65.5. Now that we've got that, we can do the same trick we did with the previous problem, and that is we'll do ounces times frequency, and then add them up, and then we'll be all done. Yes, so we'll do the total. So go ahead and compute some ounces times frequencies. I'll do the hard ones. This one is going to be 65.5. This will be 0. This will be 45.5. This will be 5.5. So I just have 3. If you could do those 3 in the middle while I get the total number of students in this particular survey, that'd be helpful. So I'm getting 52. That's my total number of students. All right, let's get some volunteers here, some real ones, since I didn't fire up the randomizer. What about the second category here, this one? What is 15.5 times 13? I mean, that can approximate about 200, isn't it? All right, 201, thank you so much. All right, now I need 25.5 times 14, which is going to be about 350, isn't it? 360? Who's got that one? 357, okay, 357. And then the last one, 35.5 times 22, which is going to be in the ballpark of 750. Ooh, 781, okay. Nice. All right, now we just have to add these up. So good. By the way, anyone, if you're lost or you're like, what's going on? Let me know. It's okay. It's okay to be lost if you ask for help. That's the best. I mean, this is good for any aspect of life, but in particular when you're learning statistics. That reminds me that as we get closer to this test, there are some of you who are anxious. If you are anxious, this is a great time to make friends in here because you have friends who are not anxious, that are confident, and you can share each other's burdens. So, please do that. It's good to work together. That's the way to do well on exams, is to work together as you study, as you talk about them, because sometimes you'll find that your friend who's super confident will have a misconception about the stuff, and you'll say, wait a minute, I thought it was this way, and they'll be like, oh yeah, thank you. So it goes both ways. Okay, did I get this right? 1456? Yeah, Oz? Yeah. In terms of we're not going to estimate the median of this. I mean, we could, but no, we're not. Yeah, and if we did, we wouldn't use these numbers. Oh yes, yeah. I guess we. Yeah. Okay. Yes. The answer is yes. Sorry, I took a minute to parse that question. I apologize. Um, okay. Very nice. Uh, yeah. And so if we asked for the mode, actually, the way I would express the mode is I would say that the modal class is 31 to 40. That's the most popular. So it'd be like a group. It's not a single number now, that group. But yeah, let's get to this 1456 divided by 52, and then we get to move on to the other stuff, and that's 28. And so this average, the average is approximately 28. It's not, we don't know for sure. I don't have, but it's good enough. This is good enough. If we need an estimate for the average, that's what we would do. So good. Okay, nice work. Let's move on to this. I know it says introduction to statistics, but we need to do, let's see, there's the main thing. I mean, you could technically, actually, you know what we should do is with this classwork paper, we're going to use number 1 as our primary example. So the number 1 there, that data set, we could put it on the back, or you could write it somewhere else in the notes or whatever. So there are different ways to talk about the position of a data point, a datum within a data set. So for example, if you have 0 siblings with that last example, let's see, or not the last one, the second to last one. If you have 0 siblings, then you're kind of at the front end of the data set. If you have 8 or 9 siblings, you're at the other end of the data set. But you can express like where you are in relation to everyone else using a couple of different things. They're related to one another. One of those is a percentile, which we aren't going to be going over today. That'll be for next week. So percentiles, but I need to mention it just because what we are going over this week is called quartiles. So percentiles you're probably familiar with. You've probably taken a standardized test and you've been given a percentile. And that percentile, we'll go over the nuts and bolts next week. But when you are told that you are in the 90th percentile, which I'm sure some of you are for whatever aptitudes you have, that means that you are smarter than 90% of your peers. If they say, like when they weigh me at the doctors and they say, well, you're in the 85th percentile for weight, that's not as good because I'm heavier than 85% of all other guys my age. So babies get weighed. I've got 2 grandsons now, and like they're both in the high percentiles for their height and weight, and so they're just big babies. But you're probably familiar with these concepts. So that's a percentile. A quartile, we're just talking about quarters. So quartiles are just, if you imagine fourths, I can't write. So if you imagine dividing your data into fourths. So let's take that piece of paper that you have and the first data set, I'm just going to rewrite it right here. We have the numbers 2, 5, 5, 6, 7, 7, 7. There's my data. And so it is as easy as you think it is to divide the data into fourths. Let me just show you. If I were to divide this into fourths, I would think of it sort of like cutting a bar cookie to divide up among 4 people. I'm first going to cut it in half, and then I cut each half in half. So if you know how to do a median, you're fine. You can do this. So I've got it in half, and now I say, well, what's the median or the middle of the first half? Well, there it is right there. And what's the middle of the second half? Well, there it is right there. And we're all done. So that here's how we'll label this. You have Q1, which is 5. That's the first quartile. The second quartile is the median. So we'll just call that the median. And then Q3 is 7. And that's it. Now, technically, there's a little bit more going on behind this, but that's really it. That's, I mean, if you can remember, do the median, then cut up the first half of data, cut up the, done. You're done. But let's see what other joys we can have with this. Let's see. Let's do, there we go. Okay. So let's take a look. Yeah, this just has words. Okay, so the foosball coach wants to know the average number of points scored by the team in their last few games. The scores are listed below. And so we have these numbers, and I've introduced another concept, the 5-number summary. Really, it's just the quartiles and then the minimum and maximum. It kind of gives us an idea of how things are spread out. So 5-number summary. So let's go ahead and get this 5-number summary for these data. I'm just going to copy, because I didn't leave myself enough room on this particular slide. I'm going to copy this, there we go, and stick it over on my, just a minute. No, that's good. Copy and delete. Okay, so let me just, bear with me while I goof around up here. There we go, there's the numbers. And so we're going to, first of all, since we're finding median, we're going to put this in order, right? 8, 9, 11, 13, 15, 19, 19, 20. Let me double check, especially with, the larger the data set, the more apt you are to make a mistake. I'm just going to go through. We have 8, 9, 11, 13. Sometimes I miss one of the duplicates. 15, 19, 19, and 20. I guess I got them all. Okay, so let's go through the procedure. We have 8 data, although you probably can tell me what the median is even now. But we have 8 data, and so where is the median? So we're going to do n plus 1 over 2, which is going to give me 9 halves, or 4.5. So right there, between the 4th and 5th datum, you have this median, and you can do this hopefully in your head. 13 plus 15 over 2, split the difference, get 14. You got it? All right, so that's the median. Now let's get these quartiles. Now you can do this a bunch of different ways, but with a small data set like this, it's pretty easy. You just say, okay, I can see where that median is. It's going to be right here, the middle of that second half of data. And here's the middle of the first half of the data. So Q1 is 10. Q3 is 19. So let's just pause, make sure that there's no confusion about why those numbers are the way they are. So it seems pretty straightforward. Okay, let's move on to another example. Let me see, what do I have in the PowerPoint? I don't know if I have any, oh, apparently nothing, just a minute. Oh yeah, this is a good one. Here we go. So just to make things a little bit more exciting, we have this table. So similar to the tables on the worksheet that I gave you. And I want to find the 5-number summary. So once again, we want the minimum, oh, I guess I never did the 5 numbers. We'll do the 5 numbers for this one. And I want the minimum, maximum, quartiles, and median. So let's go ahead and see how this works. I'm copying this. Sorry about the delay here. There we go. So I want to find the, so let's go ahead and we need to know how many data there are. So what is in for this particular data set, and then we'll go on from there to figure out where the quartiles are. So I'll give you a minute to figure out what in is. All right, looks like, do you know in? 25. It is 25, very good. Did you do that in your head? Yeah. Awesome. So yeah, so 25, I always love mental arithmetic. I think it's a good skill to have. So in is 25, and so we know that the median is going to be the 13th number, because you have 25 plus 1 is 26 divided by 2. So the median in plus 1 over 2 is 13. Okay, so let's start counting. It's a little bit of a pain. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. If the check marks are just representing each individual datum, so we're up to 9, 10, 11, 12, 13. Oh, okay. So the 13th, if I were to list these out, it would look like this, which I don't want to do, dot, dot, dot. But the 13th number will be one of these 5s over here. You know, so I usually try to just sort of tick them off, count. I get to the 13th and I'm like, okay, I get up to 13 and I'm good. It's a little tricky because it's hard to keep count sometimes. But yeah, that's going to be the median, is 5, the 13th number. And now, in order to find the quartiles, we're going to do something similar to what we just did, because I don't want to have to split the data up and find the median of the, so here's a little bit of a shortcut with large data sets like this. And this isn't large at all, but here's the way that I would do this, is to find the first quartile. I'm going to do n plus 1 over 4. It's the fourth. You take the data and divide it into fourths, and that'll tell me where this thing will be. So what is that number? That is going to be n plus 1 is 26. 26 divided by 4 is 6.5. The same rules apply to this. So the first quartile is going to be the 6.5 number. So let's start counting. We have, I'll circle them now, 1, 2 numbers, those are 3s. So 2, 3, 4, 5, 6. So the 6th number is a 4. The 7th number is a 4 as well. And so the first quartile is going to be between those two 4s. So if I were to keep doing this, 4, 4, there it is. That's what it would look like. We're talking between those two 4s. And so the first quartile is the average of those two 4s, which happens to be 4. So that's the first quartile. The third quartile is a little trickier, but it's not bad. Just think about what we're talking about here. The median is the halfway point. The first quartile is the quarter point. The third quartile, the 3/4 point. So you go 3/4 of the way through the data. So that's why it's a little bit trickier, but you can do this. Come on. So this is the third quartile. Okay, if I can only write, this is going to be 3/4 times n plus 1. So this was 1/2 of n plus 1. This is 1/4 of n plus 1. This is 3/4. We're going to use, by the way, we're going to use the exact same thinking next week when we do percentiles. If you think about a percentile, what's the 90th percentile? It'll be 90%, but that's getting ahead of ourselves. Let's just do this one so that this, I guess I can do in my head, hopefully. If you do 3/4 of 26, you should get 19.5, I believe. So now it's a little bit more counting, but let's do it. It'll be worth it. So I don't know if you want to do the check mark thing like I do. You can do whatever you want. Just a minute. I'm going to put more check marks down and I'll explain. So this is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then 1, 2, 3, 4, and 1. Okay, so let me get rid of my little circles that I've done for the first quartile. Let me just get rid of the circles. I got rid of them. Okay, so if you want to think of it this way, that these are the actual data, you'd have 2 of these, and then 7 of those, and so on. Okay, so let's start counting, and maybe I'll just highlight. Okay, so we've got 1, 2. I need the 19 and a half, so I'm up to 2. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Whew. Okay, so the 19th datum will be a 5. It's this one in particular, the second to last 5. And then the 20th datum will be a 5 as well. So that's what I'm going to do, is I'm going to average together the 2 5s. So Q3 is 5 plus 5 over 2, which is 5. Not very exciting, I know, but it sort of illustrates that you can have a quartile and a median in the same place. Look at this, we got 5 minutes, and we are on track. It's so exciting. So the 5-number summary. Let's do the 5-number summary. Minimum, quartile 1, median, quartile 3, maximum. Done. Okay, I need to peek at something before we go on. So if you pardon me for just a minute, I need to look at the homework because I can't remember, to be honest, where we're supposed to land this thing. Oh, and I've broken up the homework. Now we have 2 tabs. And I will add another tab when we get to March, but I thought that this would be the most efficient. So we have the, wait, why is this not moving? There we go. So we have, just so you know, we've got the January tab that goes up through the first exam because the first exam is the last day of January. Then we have the February tab, which will go up through spring break because spring break is the end of February. And then we'll have a March tab, and then we'll have April tab. So I think that at least we won't be scrolling forever. See, it's not that big. But if you go down to the bottom, you'll see Wednesday, do these 2 assignments. You're going to be fine here. The box plots. That's what I wanted to know, is I just need to double check. Box plots are super easy. It'll take you 2 minutes. I just want to see this to make sure that I'm doing what I need to. Yes. Okay. Oh, interquartile range. Okay. Well, we'll be okay. Okay, let's talk about box plot really quick so that you don't get scared. We got 3 minutes to do this. I have my 5-number summary. So the 5-number summary for this particular one is 4, 3, 4, 5, 5, and 8. All right, bear with me. This is, yeah, this, I got to, well, I guess we'll be going over this on Wednesday as well, but if I'm around. But here's the deal, is to make a box plot, it's not hard, box plot. What you want to do is you want to make a number line that includes all of these numbers. But here's the deal, is it needs to look like a number line. That means it needs to look like a ruler. Here's what I don't want it to look like. That does not look like a ruler, does it? Oh, sorry, yeah, you can't see it. That's not a ruler. A ruler wouldn't have that big gap between the 5, and the 8. No, that's not a ruler. Here, I'll show you what I mean by this. I need to go from 3 to 8. And so if I'm counting, I have 3, 4, 5, 6, 7. I need to put 4 lines in here. And if it's going to look like a ruler or a meter stick, those 4 lines will be approximately the same distance apart. Oh no. Oh no. My thing stopped working all of a sudden? Why? Okay, well, let me try this just a sec. Okay, well, I'll have to fix that later. Let me just draw it on the board. Sorry about the video, people. But you can imagine, and I'm flustered. Just a sec. Maybe it's in my PowerPoint. Let's see, do I have a PowerPoint with this? Do I have yeah, I have a box plot. Okay, so here's what I mean by this. Is this, yeah, this, okay, box and whisker or box plot. So you have a number line. So this is a different set of data. So just, you have to deal with it. You have this nice number line. Notice that it's marked off even increments. Then, and it includes every number between 23 and 51. Then you put a box around the quartiles. So here's the quartiles, 29 and 42, 29 to 42. That's my box. That's the box for the box plot. Then you put a line for the median. The median is 33 here. And then you put little whiskers on either end to go to the high and the low. And that's it. That's a box plot. The main thing that people get wrong about this is they'll sometimes not make their number line nice. They'll just put these numbers down on a line without spacing them out appropriately. So that's pretty much it. You can do the homework, I'm sure. But if not, we'll pick up the pieces on Wednesday, hopefully. So we'll see you on Wednesday. I'm going to stop the recording. If you want to come chat,